Energy. Okay, today we are going to do energy. You have to understand one very important point, that work is energy. Basically, you are able to do work when you have
Oh,
energy.
yeah, energy.
Yes or no?
Yes.
So, what do we generally do? We have muscular energy, isn't it? So, there is this particular law which is called law of conservation of energy.
Mm-hmm.
Law of conservation of energy. So, what is law of conservation of energy? Law of
Uh,
conservation of energy says that energy can neither be created.
or destroyed.
Exactly. Energy can neither be created nor be destroyed. Okay.
Yes.
So basically, whatever amount of energy you have, okay, energy can neither be created nor be destroyed. It can only be converted from one form to the another. It
Mm-hmm.
can only be converted from one form to the other. Okay. It can only be converted from one form to the another. So one thing you have to keep in mind, that work is energy. Simple. Work is equals to energy.
Energy. Yeah.
Work is equals to energy. You understand?
Yes.
This is the concept. Now you understand. So energy, how does the normal, change in energy takes place? Like for example, when we have food. So food has chemical energy. Yes or no?
Mm-hmm.
And we eat that food.
Yes.
So my body does what? My body breaks it down and
Which is
produces
mechanical
mechanical
energy.
energy. Exactly. It is muscular energy.
Mm-hmm.
And because it is muscular energy, so from the muscular energy, there is mechanical energy. There is mechanical energy, isn't it?
Yeah.
So
Yes.
when we are talking about the food, so it produces chemical energy. You understand? And that
Mm-hmm.
food on eating, that food on eating produces muscular energy. And that muscular energy produces mechanical energy with which we can do what? We can walk, we
Mm-hmm.
can move, we can fight. Are you understanding?
Mm-hmm.
And thereby, from the muscular energy, then we are able to do lots and lots of work. So when we are moving, okay, when we are moving, we have kinetic energy. When we are moving, we have kinetic energy. So what is kinetic energy? The energy possessed by a body while moving is called kinetic energy. So when, for example, the bullet is moving, so bullet has some mass and bullet has some kinetic energy. You understand my point? When some ball is moving, so it has some kinetic energy. And that kinetic energy is doing some work. So I will say that, whatever energy. So how do you think that, this ball is moving? When we are pushing the ball? When we are pushing the ball? Do you understand my point? So my muscular energy gets converted into the kinetic energy of the ball. That's how this conversion takes place. Where do I get the muscular energy from? I get the muscular energy from the food. I hope you're understanding. Is that clear?
Yes.
So this is the concept. So when I say work is equals to energy, what does that mean? Always understand work and energy are exactly the same, only its form is different. Everybody is doing the same, everybody is using the same amount of energy, but its form is different. For
Okay.
example, you understand, see, there is this floor, you understand, and here
Mm-hmm.
we have the box. Here we have the box. So this box basically rises from this height to a particular this height. You tell me one thing. Do you think that this box is going to wants to rise to certain height edge? Tell me. Do you think that this box wants to rise to this particular point edge? Tell me. But what is the
Uh,
basic nature? The
it's
basic.
not. It.
Hmm.
Yes.
My point is that to pick it up, it takes a lot of work. It takes a lot of energy,
Work.
muscular energy. My
Yes.
point is the basic nature of every matter is inertia. The basic nature of every matter is inertia. What is inertia? Inertia is the basic state of a person or of an object where the person at rest
Rest. Mm-hmm.
would remain at rest
Rest. Yes.
and the person in motion
Will remain emotion.
shall remain in motion. Do you understand my point? The person at
Yes.
rest shall remain at rest and the person in motion shall remain in motion. Do you
Motion.
understand my point?
Yes.
So, my point here would be what? My point here is that we have this floor, and this box wants to remain at the base only. Box wants to remain at the base. And when this box rises up to a certain height edge, okay? When this box rises up to a certain height edge, so you understand what is happening. There is this formula which is called as mass into acceleration is force. Force equals to mass into acceleration. That's a new formula, okay?
Mm-hmm.
All right. Now you understand. When we are talking about F is equals to ma. So what exactly does that mean? You see, when we are talking about the basic nature of matter, right? Inertia. So the box also wants to stay where it is, but gravity is pulling it down. Gravity is pulling it down, isn't it? So
Mm-hmm.
we have to do the work against gravity. Now, in the meanwhile, let's suppose the box is in the green position. Once the box is in the blue position, and once the box is in the black position. You understand my point?
Okay.
So my point here would be what? My point here is, my point here is that at different situations, at the green height, at the blue height, and at the black height, there are different heights, isn't it? H1,
Yes.
H2, H3. Are you understanding?
Yes.
And since there are different heights, what exactly does that mean? So to reach at height H1, the amount of work done would be little less.
Mm-hmm.
But to reach at height H2, the amount of work done is little more.
More. Yeah.
And to reach at height H3, the amount of work done would be even more.
More. That highest. Yes.
What exactly does that mean? That means that the higher you take the body up, the higher you take the body, the higher the more the work would be done. The more the work would be done.
Yes.
All right. Right. So that's
Mm-hmm.
the concept. So what I'm trying to tell you is that when we have this condition, so this position 1, position 2, and position 3 from you in what way? So the formula of gravitational potential energy is mgh, and that mgh is going to be acceleration due to gravity. G is acceleration due to gravity. M is the mass in kgs, and h is the height. The value of acceleration due to gravity is a constant value, and that is 9.8 meters per second square. All right.
Yes.
Okay. Now understand what is happening. When we have this particular box, let's suppose I tell you there is this book which is placed over a table, right?
Mm-hmm.
There is this book which is placed over a table. Now, when this book is placed over the table, this book, so the table is already 2 meters high. And from 2 meters high, I have lifted the book up to a certain height, 6 meters above the table. I have lifted the book 6 meters above the table. Yes or no?
Yes.
Now, the point is what? That my reference is important. The reference is my ground. My reference is the ground. So, from my ground, the position 1 is 2 meters high. And from my ground, the position 2 is 8 meters high, effectively, if you see.
Mm-hmm.
Right? So, my question to you is that, how much work is done? How much work is done to lift the object from, to lift the object 200 grams from the table, to lift the object which is 200 grams heavy at a height of at a height of 6 meters above the table. At a height of
So
6 meters above the table.
what's
That's
that?
the question. So, what does it mean? You tell me.
Uh, Give me 1 second. I'm just writing the.
Written.
So how much work is done to lift object 200 grams at a height of 6 meters above
Correct.
table? Okay.
Correct. Now, you see. So, when I say how much work is done to lift the object 200 grams at a height of 6 meters above the table, what am
Mm-hmm.
I trying to teach you? That now work is equals to. So, what is the. This is position 2, right? This is position 1.
Yes.
So, I am saying that, the table has already done some work here. It is already at a height of 2 meters, isn't it?
Yes.
So, it would be mgh2 minus mgh1. That's the
Okay.
formula, okay? Because you're not moving the body from the ground to a certain height too. No,
It's
you're moving it from
already
the
up.
table. So when it is
Right.
a table, it already has some stored energy. And now, whatever extra work you're doing, your muscular work is also getting stored here in the book.
Yes.
So
Yes.
that's the formula. So what is your second height? Second height is 8 centimeters, and your first height is 2 meters. So work done shall be mg. You take out common, it shall be h2 minus h1. So M is what? M is 200 grams of the book. So 200 divided by 1000. So that shall be 2 over 10, which is going to be 0.2. G is going to be 9.8 meters per second square. And that is a constant value. Sometimes you can take G as 9.8, which is approximately 10. Okay. And H2 minus H1. What is H2 minus H1? H2 minus H1 would be 8 minus 2. All right. Because my second height is 8 and my initial height was 2. Yes or no?
Mm-hmm. Mm-hmm.
So it is going to become 2 into 6, and that is going to become 12 joules. Are you understanding my point?
Yes.
So basically, I will have to do 12 joules of work. I will have to do 12 joules of work to do what? To lift the book from the
To
table.
lift the
Yeah.
yeah. To lift the book.
Understood or not? And what kind of work is this? That's my point. This is sort of a negative work done. Now, why is that a negative work done? Understand? Because we are doing work against what? We are doing work against what? There is this gravity,
Mm-hmm.
mg, isn't it?
Yes.
So mg is pulling it down,
Yes.
and we are making the displacement upwards. So the
So it's in
force is
the
downwards and the displacement is upwards.
right.
So what is the angle between force and displacement? 180 degrees.
Yes.
And cos theta at cos 180 degrees should be
It's
minus
negative.
1.
Yeah.
Are you understanding my point?
Yes.
So what do you think we have in here? We have work done is going to be Fs cos theta.
Okay.
Understood or not?
Yes.
All right. So that is the concept,
Okay.
right? So
Yes.
this is gravitational potential energy.
Mm-hmm.
Now we have one more term which is called as the kinetic energy. We have the kinetic energy. Okay. There are two terms together you have to understand. One is called momentum. Momentum you denote it with P, and P is equals to mass times velocity. So if you want to discuss the momentum of any body, you will say momentum is equals to mass times velocity. All right.
Mm-hmm.
So when we are talking about the kinetic energy, what do you think it is? The formula here is this. Understand. Do we know that every body, whenever it is moving, it has some kinetic energy into it, isn't it?
Yes.
So you understand that when we have this, let's suppose we have this box. Let's suppose we have this box. And this box is mass m. This box has a mass m. Now, when you apply a force F, so initially this box was zero, initial velocity was zero, isn't it?
Yes.
The box had initial velocity zero, yes or no?
Yes.
And when the initial velocity was zero, but when you pushed it with a force F, when you pushed it with a force F, yes or no?
Mm-hmm.
So with that force, this body made a displacement S. With that force F, the body made a displacement S.
Yes.
I
Yes.
hope you're understanding.
Yes.
So you understand when you push a body which was initially at rest, it would start moving, and you're not stopping to apply the force. You're continuously applying force, continuously you're applying force. So do you realize that it is not going to move with a constant force speed? It is going to increase its speed. I hope you're understanding.
Yes.
So there would be a final speed zero. There would be some final speed v. What is v? The final speed. I hope you're understanding.
Yes.
And when we have this final speed, what exactly does that mean? You tell me. What exactly does that mean? That, ma'am, the body or the mass m must have must have accelerated,
Yes.
yes or no,
Yes.
by or with an acceleration a, with an acceleration a. Are you understanding?
Okay.
Yes or no?
Mm-hmm.
So here what is happening, understand. So we would say that v square minus u square equals to 2as is going to be my is my third equation of motion, isn't it?
Mm-hmm.
Is my third equation of motion. So let's put in the values. So we have v square is definitely v square. U I would put 0 square equals to 2as. So here v square shall be 2as. So here displacement would be what? Displacement would be here. I would have what? Acceleration would be what? V square by 2s. That is going to be my acceleration. Are you understanding?
Mm-hmm.
And what is force? What is the formula of force? Force is equals to mass times acceleration. That's the formula of force. You understand?
Mm-hmm.
So I am saying that v square upon 2s acceleration is being applied on the body of mass m. So force would be what? Mass is m. Acceleration would be v square by 2s. So I have substituted the value of acceleration right here. I hope you're understanding.
Okay.
So force is going to be mass times v square over 2s. That is going to be the force. And now you understand. Do you realize that the displacement direction is also forward and the force direction is also forward? What does that mean? Tell me. What is the angle between the force? So this is displacement. and this is
Mm-hmm.
force. So the angle between them would be 0 degree.
0. Right.
So my point here would be work is equals to force times displacement times cos theta and cos 0.
Right.
Because here, the example that we have taken into account, what do we have in right here?
What do we have? What?
What do we have in right here? The angle between the force and displacement comes out to be 0 degree. I hope you're understanding.
Yes.
So let's put in the formula of force. The force is mv square by 2s, isn't it?
Uh, um,
Isn't
V
it?
squared over 2s. Yes.
And s is s,
Yeah. S is the displacement.
and cos 0 is 1.
1.
So here displacement cancels displacement, so work should be mv square by 2.
Yes.
Are you understanding my point?
Mm-hmm.
So this is kinetic energy.
Okay. So the formula for kinetic energy equals to W
Half mv
equals to
square.
mv.
Correct. So work is basically energy, and that would be half mv square.
Okay.
Are you understanding my point? So that's how we derive the kinetic energy formula, which is half mv square. All right.
So kinetic. Okay.
So
One
basically,
half.
when we say that, we have two formulas now. We have momentum as well. Momentum is mass times velocity is momentum. Okay. And kinetic
Mm-hmm.
energy is half mv square. Now there are two things. Okay. So obviously, when body is moving, only then the body will have momentum.
Yes.
And obviously, when the body is moving, the body will have kinetic energy. Energy is basically the capacity to do work. Capacity to do work. I hope you're understanding.
Mm.
I hope you're understanding.
Yes.
So when we are talking about the momentum, the capacity to do work, what do you think we have in right here? Just see. So can I say kinetic energy is half mv square?
Yes.
Can I say multiplying both sides with m, multiplying both sides with m? Can I do that? How what
Yes.
difference would that make? Kinetic energy times mass would be
Mm-hmm.
half mv square times m. Do you understand?
V squared times m. Yes.
What is m times m? What is m times m?
Okay.
M square. And v square is already v square. So it shall be kinetic energy times mass. Are you understanding?
Mm-hmm.
So
Mm-hmm.
2 goes here, so it becomes 2 into kinetic energy into mass. And that is m square v square, isn't it?
Yes. M squared V squared.
So m square v square shall become what? mv whole square.
Mm-hmm.
And mv is nothing but momentum. P.
Momentum. Yes.
So can I say p square is equals to 2 times kinetic energy into mass? Yes or no? So that's the
Oh, which
relationship
is the
between
momentum.
momentum and kinetic energy. So 2 times kinetic energy into mass
Man.
is the
Okay.
formula. So how do I remember that P is going to be under root of 2 kinetic energy into mass. Someone, are you understanding the point? This is the formula for momentum. Any doubts into this?
Right.
So what will I do? I will give you a boost. I will give you some amount of energy, either through my words or through some food article or something.
Okay.
So if I have to provide you energy, only then you would be able to do work with even more energy. So that would become what?
Yes.
500. So 500 into 625. Are you understanding?
Mm-hmm.
So what is it going to become? It is going to become 625 into 500. So that shall be 5 times 525. 5 times 2, 10. 10 times 2, 10 times 10
So
plus 2,
20
12.
or
And
12.
5
Yes.
times 6, 30. And
30.
31. And this much. Now the car is moving with 312500 joules of energy, and initially it had 50,000 joules of energy. Are you understanding?
Okay.
Are you understanding my point?
Yes.
What is the point? So work is basically final energy minus the initial energy.
That's sure.
That much
Yes.
work is being done. So final energy is 312500 minus 50,000. So it would be what? If I'm not wrong, 625 into 5,000. So if I had 25 to, yeah, 325. So basically you subtract 50,000,
Mm-hmm.
right? So you will have 2,500 basically, and then 26. This much joules of work is being done. So can I say work done is equals to half m final V square minus half m initial U square? This is called work power energy.
Okay.
This is called work energy theorem.
Oh, right. Work energy.
Do you understand my point? That you know
Yes.
whatever the change in the energy is, that change is my work done. I hope
Mm-hmm.
you are understanding the concept.
Yes.
Any doubts in this?
Mm-mm.
All right, that is the concept.
Okay.
So this is how you have to understand. So similarly, but we have two formulas for work done. We have two formulas work done: half mv square minus half mu square. This is in terms of the kinetic energies. Okay,
Mm-hmm.
this is the thing. And work is also equals to mgh2 minus mgh1. Okay,
Yes.
these are the two formulas of work. Another formula of work done is what? Force times displacement times cos theta, depending
Yes.
upon what information is actually given to you in the question. Do you understand? Now, let us suppose there is another question. The question says the velocity of a body is tripled. Calculate the kinetic energy. Calculate the change in the kinetic energy of the body. Calculate the change in the kinetic energy of the body. Now, what is this question? It says the velocity of a body is tripled. So let us suppose the body might be having a certain mass m. I hope you are understanding.
Mm-hmm.
So when the mass of the body is m, what would you say? You will say that let's suppose the body's mass is m. So the kinetic energy initial would be what? Half m initial speed square, isn't it? Half m v
Yes.
square. Let's suppose v is my initial speed. V is my initial velocity, isn't it? So now it says kinetic energy is the double, the velocity is tripled. Velocity is tripled. So what do you think
Mm-hmm.
my new velocity becomes? My new velocity will become 3v. So my kinetic energy final shall become what? Half m 3v square. Are you understanding?
Yes.
So half m 9v square, because 3 square is 9 and v square is v.
Mm-hmm.
So that shall be kinetic energy final. So kinetic energy final is going to be 9 by 2 mv square, and kinetic energy initial is going to be 1 by 2 mv square. And when you divide it, what do you think you get? M cancels m, 2 cancels 2, v square cancels v square. So kinetic energy
Mm-hmm.
final upon kinetic energy initial is basically 9 over 1.
Line over one. Okay.
Okay, that's the ratio. But the question is not asking you the ratio. The question is saying what is the percentage change? That's the ratio. If they ask you the ratio, so kinetic energy final is to kinetic energy initial would be 9 is to 1, isn't it?
Right.
But the question is asking me the percentage change. What do you think would the percentage change be? The percentage change would be the percentage change would be kinetic energy final minus kinetic energy initial over kinetic energy initial into 100. That's the percentage change.
Okay.
So if I have the kinetic energy final over kinetic energy initials ratio as 9 over 1, so it would be what? 9x minus 1x over 1x? Because obviously kinetic energy final could be written down as 9x and kinetic energy initial could be written down as 1x. I hope you're understanding.
Yes.
So what exactly does that mean? You tell me. So 9x minus 1x over 1x into 100. So wouldn't that be
200. Yes.
8x over 1x into
8x
100?
over 1x. Yes.
So that means the energy has increased 800 times.
Times.
Are you understanding my point?
Yes.
Okay. So that is the concept. Understood or not?
Mhm.
Right? So whenever the question talks about the change in the kinetic energy, follow this particular formula. Kinetic energy final minus kinetic energy initial into 100. Now let's suppose we have another question. Did you understand this question? Is increased by, if its velocity is increased by 5%. If its
Okay.
velocity is increased by 5%. So now in percentage increases question, right? There's a different method to solve these questions. Now, what is the method to actually solve these questions? Is just see. So let's suppose what do? We say, let's suppose there's a body of mass m. Okay. There's a body of mass m. Yes or no?
Mhm.
When the question talks about the body of mass m, so I do not know the initial velocity. I would do what? See, this method you will follow only in this method actually you can follow in any situation. Okay. The previous question, the one I did, this new method you can apply everywhere.
Mhm.
So I'll say let the initial velocity be 100 meters per second. Can I do that? I can assume the initial velocity to be 100 meters per second.
Mhm.
Why am I assuming that? Because to calculate some percentage of 100 is easier. That is why I'm calculating the percentage velocity. I hope you're understanding.
Yes.
So when I say that, let the initial velocity be 100, so the initial kinetic energy would be what? Half mv square. So it would be what? 10,000 m over 2. That would be what? 5,000 m. That would be my kinetic energy initial. Is that clear? I hope you're understanding the point, right?
Yes.
Now the question says the velocity is increased by 5%. That means the new velocity would be what? The new velocity would be what? 5% of 100 plus 100. 100 cancels 100, so it is going to be 5 plus 100. So it is going to be 105 meters per second. I hope you're understanding. That is going to be my new velocity. Yes or no?
Mhm.
Because 5% of 100 has been increased. Increased as in
Yes.
5% of 100 has been increased to 100. Because initially the previous velocity was 100 and now it is more. How much more? 5%.
5%.
But 5% of what? 5% of the original velocity.
Mhm.
So it is going to be 105 meters per second, isn't it? Isn't it? That's the new
Yes.
velocity. So my new kinetic energy final shall be what? Half m v square. So now new velocity is 105 square. So that
Yes.
shall become 11025 m by 2. Which if you cancel, you get 2 times 1 and 2 times 5 and 2 times 5 10 and 2 times 1, okay, and 2 times 2 4.5. So it is going to become 5512.5 m. That is going to become my kinetic energy final.
Mhm.
Yes or no?
Yes.
So the question is asking me the percentage change in the kinetic energy. What is the percentage change in kinetic energy's formula? Tell me. That would be
So
kinetic
now
energy final minus kinetic energy initial
initial,
over kinetic energy initial into 100.
initial.
Yes or no?
Yes.
So you simply put in the formula. What is the formula? What would you say? You would
So
say
now,
5512.5 m
yes.
minus 5000 m over 5000 m into 100. So that would become 512.5 m over 5000 m into 100. So this
Mhm.
cancels this, m cancels this. It is going to become 512.5 over 50. You understand?
Mhm.
And then just solve. So 5 times 10, 5 times 10 to 5. It is going to become 10.25% increase in the kinetic energy.
Yes.
So there is no set formula for this percentage increase. They would give you the percentage increase in the velocity. They would give you the percentage increase in the velocity, the percentage increase in the velocity, or the percentage decrease in the velocity. You understand my point?
Mhm.
And then they would ask you that if velocity is decreased, how much is the percentage decrease in kinetic energy? And if the velocity is increased, how much is the percentage increase in kinetic energy? Do you understand my
Okay.
point?
Yes.
That is the question. I hope you're understanding my point.
Mhm.
Any doubts in this?
Mhm.
Right? Similarly, when we are talking about, right? So now calculate this question. It says calculate the percentage increase in the calculate the percentage increase in the kinetic energy of a body. Can you try it on your own? If the velocity is increased by 8%. Tell me. Can you try out this question,
Okay.
Aditi?